Hello, my name is Hyugyum Kim from South Korea, and my presentation title is Hooking Tweakable Even-Mansour Ciphers. My content is like this. For introduction, I want to give you my research motivation, starting with authenticated encryption. Then introduce Tweakable block cipher and Forkcipher. At the end of the introduction, I will show you my contribution. Because my research is in proof of security scope, I also want to give you my proof sketch briefly. Introduction section. I think everyone here are familiar with authenticated encryption. Authenticated encryption is a type of cryptographic scheme that serves encryption and message authenticated code. This scheme assures privacy and integrity on the data, and there are many researches on how to make authenticated encryption. The primary research is focused on combining encryption schemes and MAC. MAC then encrypt, MAC and encrypt, encrypt then MAC are the example. But it is natural that directly making authenticated encryption scheme will be more efficient than combining two different schemes. OCB is representative authenticated encryption scheme. AEAD, authenticated encryption with associated data, is a somewhat developed version of authenticated encryption. It has additional input associated data that doesn't demand privacy but demand integrity. By adding associated data, AEAD can perform every cryptographic functions. If you want MAC, you can make only associated data input and get tag. If you want encryption, you can make message input and get ciphertext. For authenticated encryption, you can make message input and get ciphertext and tag. The question starts here because AEAD contains all symmetric cryptographic structures. If someone wants to make AEAD, the primitive doesn't have to be a block cipher. From this idea, many researchers studied new cryptographic primitives. Tweakable block cipher is the pioneer. Tweakable block cipher has additional input compared to block cipher, the tweak. Tweak is a public input that makes usability on the block cipher. ZCB is the representative tweakable block cipher based AEAD. It makes some revision on OCB, and in 2019, the next primitive arrives. Forkcipher makes additional output to tweakable block cipher. It seems that the message input is forked to two different outputs, C0 and C1. That's why the cipher is the Forkcipher. The author of the Forkcipher also suggested corresponding AEAD. PAEF is one of that, like the right below. This is the table for AEAD according to primitive ciphers. These AEAD schemes are the most basic AEAD schemes. You can see OCB has a birthday bound, and the others have full security. The authors of Forkcipher emphasized that PAEF has no constant for cipher call. That means fast as short message. From here, we started our research. Forkcipher was new cryptographic primitive, therefore there were no research on Forkcipher with probable security perspective. We set probable security model for Forkcipher and also the most simple Forkcipher structure, FTEM, Forkcipher Even-Mansour. And we proved FTEM has 2/3 of n-bit security, which means forking do not degrade the security. Next, our security proof section. We first want to show you how we construct FTEM structure. Below is two-round Even-Mansour construction. In 2015, the security for two-round Tweakable Even-Mansour construction is proved. They substitute keys in Even-Mansour to Tweaky. We don't make detail about Tweaky today. From two-round TEM, we made FTEM structure like this. Because two-round TEM uses two different permutations and two tweakies, we made fork on two-round TEM with one more permutation and tweaky. If you think one round TEM as permutation with masking tweaky at forward and backward, FTEM can be thought as one round TEM, then fork, and one round TEM respectively. In provable security, when we say some construction is secure, it means the construction is indistinguishable with ideal random construction. For a block cipher, it will be random permutation, and for a tweakable block cipher, it will be random tweakable permutation. Then, for forked tweakable block cipher, what is its ideal symmetric construction? We made it as two concatenated tweakable permutation. It means if you made construction query to ideal world oracle, the oracle returns two outputs of different tweakable permutations, tilde q and tilde r. We proved security of FTEM with H-coefficient technique. Briefly speaking, H-coefficient technique separates all possible events with bad and good case, then upper bounding bad case probability and good case probability difference. We can prove its security. We showed a brief sketch of our proof. We have 5 bad cases, and this slide shows representative 4 cases. Because permutation P1, P2, and P3 are public permutations, there can exist collision with permutation and FTEM structure. And FTEM uses tweaky. There can also exist collision between distinct FTEM queries. The black bar means collision between FTEM permutation, and white bar means collision between FTEM queries. For example, bad 3 means two different FTEM queries made collision with permutation calls individually, and make whiteboard collision between them at another permutation. With these bad cases, we could upbound bad probability and good probability difference like below. The total security is like this. It seems somewhat complicated, but the point is, it has 2/3 of n-bit security, same with two-round Even-Mansour. The TEM paper showed tweaking do not degrade the security of two-round Even-Mansour, and we showed forking also do not degrade its security. This is our summary. Forkcipher is a cipher that has one input and two outputs, and efficient in short message AEAD. And forked tweakable Even-Mansour, the most simple model of Forkcipher, has 2/3 of n-bit security, same order with two-round Even-Mansour. And there are some natural ways to expand our result. Extend the fork round, or multi-fork, and multi-user security. My presentation is over, and thank you for listening.